In lesson 10.3, we're going to be talking about composite figures and finding the area of a composite figure. Here, the definition says a composite figure is made up of simple shapes such as triangles, rectangles, trapezoids, and circles. We know that something composite means made up of more than one, so it's a combination. We're also going to be talking about a couple other area topics. Now, when we talk about finding our area of our composite figure, it says we're going to use addition or subtraction to find the area of our figure. And I want to let you know that different people will use different strategies. So there's not always just one way that these problems have to be done or solved. So for example, if you take a look at example A, we're going to talk about finding the area of each of these figures. Do we have a formula to find the area of something like this? No, not one single formula. We'd have to talk about dividing the figure up. And you can see that, well, we could split it into two rectangles. I could split it here horizontally. I actually could also split it here vertically. Or sometimes finding the area, some people will extend and make one big rectangle and then subtract out this square in here. So any of those strategies would work. I'm going to go ahead and just split mine right here. So if I'm taking a look, I have my two rectangles. I know rectangle is base times height. So here my dimensions would be 3.1 times 3.4. And when I calculate my area and I multiply those, I like to just write the area in each section. So when you multiply 3.1 times 3.4, you get 10.54. And what I want to emphasize to you is we're not going to round. This is an exact answer. I am not going to round that to 10.5. When I can use an exact answer, that's what I want to use. Now, looking down below, I know that this rectangle here, what I'm going to think about as the height is 3.7. But I know I can't use 3.8, right? It has to go all the way across. So all the way across, 3.1 and 3.8 would be added together for my total length. So when I go to find my area here, I'm going to be taking 3.7 times 6.9, multiply those, and again, I want an exact answer if I can. It comes out to 25.53. We know that if we're going to look to find our area, we're going to take our rectangle plus our rectangle. We need to add one region plus the other. And in our case, we're going to add our two numbers together. We would find that we would get 36.07 square centimeters. And again, labeling our answer is important. Now, as I said before, that's not the only way that you could do that. You could have split your figure going vertically, or you could have extended, and you could have thought about finding the area of the whole figure and subtracting out this rectangle right here. Taking a look at figure 2, well again, it doesn't really have a name for this figure, but what I can see here is I can see a triangle and I can see a semicircle. And what we could think about doing for our strategy is taking our triangle and then go ahead and subtracting out our semicircle. So that's going to be our strategy. Let's go ahead and do some calculating. Now, what are we going to use base and height? I do not have the full length of this. Hypotenuse, it's right triangle. I could definitely calculate it. But actually, my triangle base and height meeting at the 90 degrees, I'm going to use my 18 and 26, right? So if I were working here and I wanted my triangle, I know 1/2 base times height could do as so. And I need to subtract out my semicircle. Now, when I figure this, 1/2, 18, and 26, I get a 234. So again, sometimes I like to write that in there. I need to think about subtracting out my semicircle. We know a circle is pi r squared. Here, my radius is going to be 4.5, right? So the only thing that we have to remember is it's half of the circle. So I'm actually taking 1/2 times pi r squared. Now, if I wanted to simplify this in terms of pi, I would take the 4.5 squared, and then I would take it times half. When you do that, 4.5 squared times half, you actually get 10 1/8 pi. So in terms of pi, this is about all I could do with that answer. Now, our textbook would probably write that a little differently. They would probably take this mixed number and put it as an improper fraction. So 81/8 pi. And this would be our square feet. A lot of the times, though, here in our composite figures, we will calculate that out. And so we would just go ahead and subtract semicircle from triangle and round it off. Looks like to the nearest hundredth, I get about 202.19 square feet. Again, if I'm estimating here, I'm going to give the approximation symbol. Okay, so there may be, as you go along, sometimes at the very end when you do round, especially mostly when you're going to be working with pi, and sometimes where you're going to have some different strategies that you could use to solve. Let's take a look at example B. In example B, it says that assume the following diagram has right angles. What is the area of the figure? So again, I'm going to look at dividing this up. I could divide it vertically, I could divide it horizontally. Either way, it doesn't really matter. So my top rectangle here, it looks like 6 times 2, that's going to have an area of 12. Now this is 3, but it's not 3 by 5. If this is 2 and this is 5, this is going to have to be 3. So a 3 by 3, that's going to have an area of 9. So as I go to calculate, add those together, I'm going to find out 12 plus 9, my area of my figure is 21 square feet. In question 2, they ask us, how would the total area be converted into total square inches? Well, let's think about that a second. Most of the time, kids will think that you multiply by 12. That's actually not correct. There are 12 inches in a foot, but that's a linear foot. And if I had a square foot, I'm going to kind of sketch over here. One square foot would be 1 foot by 1 foot. How many inches would that be? Well, we know that in 1 foot there's 12 inches. So there would be 12 inches going this way and 12 inches going this way. So how many inches would that be? How many square inches? Well, if you think about it, you're dividing it up. So how many would we have? Yeah, 12 times 12, we'd actually have 144. So in 1 square foot, there is 144 square inches. What would we need to do? We would need to multiply by 144. Okay, so how many 1 inch by 1 inch tiles would need to cover this space? Well, a 1 inch by 1 inch tile is asking for square inches, right? So we're going to take 21 times 144, and we'd actually find out that it's 3,024 times. Now that's assuming that we aren't going to make a bunch of mistakes or have any broken tiles. This would be the exact number. We know typically that if you're going to buy those, you may up that estimate a little bit. In question 4, we're kind of given a question. We're going to go shopping. We're going to go to Menards, and it says that the tiles can be purchased in 10-inch by 10-inch sheets for $2.98 per sheet. If the tax is 6%, what is the total cost for the tile? Okay, well, if I have a 10-inch by 10-inch sheet, how many tiles are on that sheet? Well, 10 by 10, that would be 100 tiles, correct? So we know that if we have 3,024 tiles needed and each sheet has 100, well, when we divide that, you swing your decimal over 2 places. Again, assuming we're not making a bunch of mistakes, we'd need 30.24 sheets. Now, can you buy 30.24 sheets? No. So we know that we'd actually need about 31 sheets of tile. Now, how much is it going to cost me? Well, our 31 sheets of tile are $2.98 per sheet. So I'll go ahead and multiply that. Well, my multiplication here, this 92.38 would be the subtotal. So this would be before tax. And now I need to think about a 6% tax. So I need to figure what 6% of this is and add it to my total. Or when I figure 92.38, if I need 6% in addition to, I'm just going to multiply it by 1.06. Because really this is saying 100% of my 92.38 plus an additional 6%. When I multiply that out, you get something that looks like this. Now we're talking dollars and cents here, so we know that if we're going to round nearest dollar and cents, 92.28, well, that's going to stay the same, and so we're going to have $97.92 for our cost. Down below that, I have a challenge, and my challenge for you is to simply find the area of that shaded region. And I'm not going to tell you how to find that area of the shaded region, but if you figure that out, you can go ahead and bring it in and show me, and I may have a little small reward for you. Okay, if you have further questions, please stop in and see me.